Welcome everybody to IIoT World's Energy Day. And we're delighted that you can join us. We're expecting a couple of thousand colleagues to be dropping in throughout the day. And welcome to everybody. Now, obviously all of this is being recorded and many folks will be watching this later. But again, warm welcome to everybody. Just a bit of housekeeping. You'll have seen there that we have the first session coming up, and I'm delighted to be moderating that, and we'll come to that in a few minutes. But we have a full day's program. You'll have seen that there is a session around oil and gas in IoT implementations. There's a session on electrification of transportation. There's two sessions later on cybersecurity, which is a current hot topic, and on the role of AI in energy management. Now, throughout the day, as we go into the different sessions, if you're logged in on the IIoT World event platform, feel free to use the chat in there to let us know how it's going, share information with yourselves. That is a public chat. If you have any questions throughout the day for a particular panel or panelists, then please put that into the, if you like, the Zoom window in the Q&A section. We'll be watching the Q&A section and picking relevant questions. And there are some prizes and awards being given out as well from IIoT World for questions that are being asked throughout the day. So to keep the whole interactivity going. So with that, we're off and running for our first session on how digital solutions have changed during the energy transition. We've been talking about, how digital solutions are changing the game for many years. But on today's panel, we want to kind of dive in, what's changed, what do the folks see happening now? And I'm delighted to be joined by an excellent panel to kick off with Pete, Vasant, Jack, and Susan. What we're going to do is I'm briefly going to ask each of the panelists to introduce themselves briefly. We'll then go back around and we want to get some opening statements from everybody on what they think about this topic. And to cut a long story short, we'll then cut into a good panel discussion. Hopefully we'll have a good bit of robust discussion going. And again, anybody, if you have any questions at any time, please put them in through the question and answer in the Zoom, and we'll take them as we go through. So we should be chatting for about 45, 50 minutes. So with that, let me introduce our panelists. Pete, good afternoon, sir. Can you do a quick introduction?
I can. So good afternoon, good morning, everybody. Pete Davis. I like to intro myself as a dad, husband, proud dyslexic and digital engineer. And what I mean by digital engineer is I've worked in the power sector for the last 12 years, always on that boundary between operations, trading and IT, and look to really obtain the outcomes, the value that has really been very heavily promised in the last 3-4 years, but really has been around for at least 10 years.
All righty. Thanks, Pete. And Susan, good morning.
Good morning. I'm Susan Maley. I work for the Electric Power Research Institute. We collaborate with utilities from around the world. My background is in engineering. I came up through the Department of Energy, so I have about 20+ years in the energy sector, working mainly in sensors, controls, and now analytics.
Thank you, Susan. And we truly are, in today's world, we're going right across the globe. So Vasant, good evening.
Good evening, Kevin. Good morning and good afternoon to everybody. This is Vasant. So I'm basically an engineer, and then I did management, and then I'm studying analytics. I'm part of Frost & Sullivan's Energy and Environment practice, and I work as a consultant in the research and advisory firm, where I work with clients on digital transformation topics, not just in energy and power, but also across process, discrete, and hybrid industries. So looking to bring all that experience and thought leadership that we have done with our research and advisory so far to this panel.
Thank you. And Jack, good morning, sir.
Thank you, Kevin. Good day, everyone. I'm Jack Sherman, Chief Executive of UMS Group. UMS Group is a global consultancy based in the US, the Netherlands, Manila, Australia. We serve the energy and utility sector have for almost 30 years now. We help clients with digitalization, the energy transition, and readiness for the future. I'm looking forward to sharing with you today our experience and some of the insights we've gleaned over the last several years, helping clients navigate the transition, to find innovative use cases for the digital solutions in their business, and identifying best practices in two key enabling areas: organization and technology evolution.
All righty. So, folks, before we dive into the actual topic, obviously, the entire day would not be possible without the sponsors: Hitachi, Fortinet, HiveMQ, Verve, and Eurotech, and Uniper. Uniper are kindly the sponsor of this session. So with that, I want to call on Pete. Pete, you know, we've been talking about digital solutions and what's changed during the energy transition. So from your perspective, what has changed recently or over time, or what are your thoughts on this?
Yeah, so at Uniper, we've really been at the heart of the energy transition, predominantly based in mainland Europe with our own assets, but helping clients globally. And for me, a number of the digital solutions are the same, but how you use them and the value that can be obtained from them is different. So take, for example, advanced condition monitoring, or pattern recognition, as some people call it. We started doing that 12 years ago around reliability and availability, because that's what was really important for the assets. But today, a lot of that value is coming from changing our maintenance strategy so we can reduce cost and reduce risk. So it's still the same tools, but how we look at them and the outcomes we're chasing is different. So that's the first thing. The second thing is business cases around digitalization are hard. And what I mean by that is they're different from the traditional investment cases that you would have for building an asset or upgrading an asset or performing an outage. It's quite clear what you're going to technically do, and that's then what the asset will do for a number of years. Because of the nature of changing markets and a digital solutions flexibility, how you value that changes. So how you write business cases for these such things, it is a different approach that maybe in some cases our industry isn't so well equipped for. And the final thing, which is still a driver, and I hinted at it in my intro on the 3 years, big promises of digitalization. Well, because of these big promises from the likes of Google, Facebook, Microsoft, the big players, the trillion-dollar companies of the world, everyone thinks this is really easy and straightforward, or you can just put an AI tool in and it solves everything. Well, the reality is engineering is still complex. The analytical side, the AI side, machine learning side can offer a huge amount, but you still need strong domain knowledge in tandem with that to execute and obtain the value. We are not at the point yet where you can apply a human brain-sized neural network and it run your whole asset. It doesn't work like that. You still need good engineering practice to back everything up. And that's how we in Uniper have found the value, through using the same solutions, but changing with the market, changing how we value stuff, and then backing it with strong engineering.
All right, thanks, Pete. And Susan, when we talk about digital solutions and the way they've changed during the energy transition, what's EPRI's point of view on this?
Well, Kevin, let me just start out by saying I want to reinforce everything Pete said. We observe a lot of those same things when we're trying to work towards things that are in the development stage, towards things that are in the application and deployment. So let me just reinforce all of what he said there. From our perspective, the energy transition has so many facets to it. So if you think about that in terms of all of its parts and pieces, we think about new technology, we think about decarbonization, we think about using the existing assets, introducing renewable assets. But what that creates is a big set of new dynamics, very dependent on data. And so we have high rates of change, new dynamics. In theory, transformational changes, workforce evolution, lots of sustained pressure on performance, reliability, and cost. So all of that is a set of dynamics and complexities that are different for utilities, from one utility to another with their asset mix, the direction that they're going, the cost pressures that they have. So data becomes more valuable to them in order to make these decisions that are dynamic and complex. So the energy transition may be different experience for every utility, depending on where they're located and the resource mix. So how do you get value out of that data and the analysis? And I think one of the things that we've recognized that's important for that digital transformation, the energy transition, is that modernization of your data management and infrastructure. Now, as an engineer, I don't have an IT background, but that role of IT in plant operations is paramount to any successful transition. So if you're going to want to make decisions off of your data, then you really need to engage those roles in engineering, like Pete had said, those subject matter experts. You also need data analysts, and you need IT to partner with you through these things so that you can get something that's valuable, practical, secure, that utilities can use. We're built out of engineers, not necessarily IT. So that role of IT OT is just a constant conversation as to how we introduce those integrated teams and building those things out. So the use of data, targeted outcomes, potential value, again, will vary. But that key enabler is that diverse and dynamic set of outcomes. We really need to think about what are those automated data connections, data integration, and secure transfer of data, either within your company or out to others, to allow that to happen. So that, again, that architecture, that infrastructure, that's scalable, modular, secure is foundational. So whatever that energy transition looks like for a small utility, a large utility, and it's going to allow them to make some decisions based on the risk tolerance and the data that they're collecting. And then it'll help them inform where they have gaps, where they have challenges, and be able to kind of pull in an integrated team. So that's sort of the pulpit I'm preaching from recently when it comes to the energy transition.
No, thanks. And taking notes here in terms of, yeah, the whole, we come back to data, and Pete mentioned it as well in terms of the workforce, right? Because I'm a technology guy. I live in the world of technology, all the gadgets. But the technology, Pete, you mentioned it, you know, we don't have a neural network yet or whatever. But Vasant, from Frost & Sullivan, where do you see this, how digital solutions and how they've evolved?
Yeah, sure, Kevin. So from my perspective, so I see two things happening in parallel because of the energy transition. One is the industry itself, from a very stable point of view, has become a very dynamic industry, because you have competition increasing from renewables, which means you have different fuel mixes depending on, like Susan mentioned, which country or region that you are in. But also at the same time, which means that the needs of the plant operators have changed because of this, and the operating patterns have been they have changed, which means that the solutions that they are using to for operations and maintenance, for example, their needs have also changed. And in parallel, the second point of view is that the OT-IT integration, that value proposition itself in terms of the whole automation perspective has evolved with time, especially with what, like Pete pointed out, the likes of Microsoft, Amazon, or IBM, what they bring in terms of value to these existing solutions. So those two have happened in parallel. And from our point of view, and we are in a situation right now where that integration has brought about new solutions to what's already there. For example, like edge and cloud, which means a different value on top of what's already there can be derived out of existing solutions. And that feeds into the requirements of operators because of what's changed, the dynamics itself. Moving on, like for example, we're talking about sector coupling these days, like integration of electricity and gas systems, which means that looking ahead in this decade, I think the need for managing these outcomes and expectations will be very key, because digital transformation is not about the solution, but about business objectives for operators. Driven by the business objective, the solution needs to respond to it. So the business objectives, when it drives these solutions, that is where I think a lot of value is going to be derived out of from this evolution that digital solutions have witnessed so far, in my opinion.
Alrighty, no, thank you. And again, the whole thing about, it's not so much that we've suddenly had a eureka moment with a brand new technology that, oh my God, it's fixed everything. It's kind of the same old stuff, but applying it in different ways. Jack, from your perspective, how do you see digital solutions playing out these days?
So Kevin, I think that as you say, it's not one major shift. It's a patchwork quilt of many trends and new directions, new possibilities. It's clear digital solutions is one of the most rapidly changing parts of our business these days. But if you look underneath the covers to see what's driving it, there are a host of external factors, decarbonization, climate change, et cetera. But there are also a set of enablers without which it wouldn't be happening. And when I look at the enablers, we see four primary organizational enablers: digitalization of business and operating processes, decentralization of IT decisions and investment priorities, transferring authority from IT over to the lines of business, data literacy and democratization of data ownership across the organization to get the right data to the right place for anyone that needs it at the right time. And then the convergence of IT and OT, which is producing greater efficiency through resource sharing, eliminating conflicts that have been obstacles to effective digital solutions in the past, and enhancing overall security as we begin to see a common set of strategies for both physical and cyber security. Complementing those organizational shifts, we're seeing technology evolution in multiple areas. Vasant mentioned the cloud, so software development and storage in the cloud are driving IT costs lower and development times shorter. AI and machine learning is complementing new technologies like image capture and analysis from aerial sources, whether it's drone or helicopter or satellite vision. An explosion of new sensor technologies. I've been astonished at the plethora of new capabilities that weren't even envisioned as possible just a few 5 years ago or so, where for 10 euros, you can put virtually any device you want out there in the field on an asset, and you can measure acoustic signatures, vibration signatures, angular momentum, many things that are going to be vitally important in understanding the condition of assets and the risk that those assets present, and automating decision making for that. So fueling new decision support digital solutions. Grid edge computing is significantly increasing the efficiency of our data operations, and at the same time pushing decision making and control out to the far reaches of the business. And digital twins are accelerating our ability to manage risk and also increasing the effectiveness of teams in terms of collaboration and decision making, with almost 24/7 availability of data and models. Taken together, all of these are driving dramatic change in digital solutions from a decade ago, when digital simply meant data collection, analysis, and decision support. And today, they're becoming more mission critical and meaning different things. Data synthesis, extension, prediction, simulation are all new elements that are being embedded into these digital solutions. So understanding and leveraging the enablers, I think, can position you much more effectively to successfully navigate the complex environment we all operate in today, and enable us to set better priorities and get greater value from the investments in digital solutions.
All righty. Now, for all the folks listening in, please, if you have any questions, feel free to publish them or put them into the Q&A, and we'll come back to them. But I've been taking notes here, so I have a bunch of things that I'm going to come back and challenge some of the panelists on. Pete, if I may come to you first, you mentioned asset, right? Now, my guess is that when you say asset, we're talking like a power station, right? It's not a particular device. But you mentioned that, we're kind of using the same tools. We're just using them for different reasons and different business cases. I suppose to make it real at Uniper, any examples to kind of, explain to people what's actually been changed?
Yeah, so I hinted at one for advanced condition monitoring, but when we first, so our advanced condition monitoring, effectively, we are using machine learning to detect faults in an asset. And then that in turn allows you to improve your reliability. And we wrote our original business case for our gas fleet on that, and it paid back within 6 months, just focused around availability and reliability. Because in the early 2000s, those units were base loading top of the merit order. Fast forward 12 years, we're now in a state where rightfully the renewables are taken first, and they should be, and we need them to be. So what we're asking our assets to do is operate differently. So instead of pure reliability and availability, we're looking at things like availability in the money. And that means then that you need to look at your cost base for maintenance and the timing of your maintenance. Now, something like advanced condition monitoring in that space is, if you have enough confidence from that advanced condition monitoring, along with traditional methods like vibration and inspections, etc., you could change your maintenance strategy. So instead of doing a pure time-based maintenance on pumps, filters, you could do a condition-based one if you have the confidence. So the value, yes, advanced condition monitoring paid back really quickly on availability and reliability, but that's not enough to pay it back today. So you've got to pay it back through cost reduction, risk reduction on your maintenance. So that's one example. Another one is take thermodynamic modeling, for example. Everybody knows about these sorts of things. Physics-based modeling, still very valuable. They were super valuable when we chased efficiency and looking for reducing the amount of fuel you're consuming. But not many people chase efficiency anymore. So what's the value in a thermodynamic tool? Well, the thermodynamic tools start to become valuable when you're looking at low load operation. How low can I take my asset? What's going to happen to the temperature and the pressures if we go below design? What changes should I make to the plant if I do certain things? And that's what we've used in Uniper now to look at that low load operation. Plus, we've looked at this availability in the money, because you get price spikes in a lot of liberalized markets now. That extra 3 megawatts from your asset becomes really important and really valuable at certain points in the day. So understanding where maybe you could just push the unit for 2 hours, 3 hours, take that extra price spike while still remaining within your tolerances, but running a little bit above design, is worth it. And your thermodynamic tools are valuable there, which we never thought we would use them in that way 25 years ago, actually, to be fair, when we started using them. And we don't really look hugely at efficiency anymore as a result. So they're 2 examples. And I could probably go through all the solutions that we use and give that type of example of how it's changed and how the value is still there but it's different how you look at it.
And I'll come to Susan in a second, because I think Susan wants to add, but there was a question in there as well from Phil Wolf, kind of going, kind of the opening statements, a lot of it was kind of the standard digital transformation, IT, OT, but he was calling out, is the energy transition driving any of this innovation? And I think your examples there in terms of the new business cases, the market models, the ability to be able to whatever, spin up or spin down your asset, depending on in ways that you never thought before. So that the energy transition is driving that, right?
Hugely so. We can't deny it. Humans, we're amazingly fickle, and it's never our problem until it's in our backyard, is it? It's you can live on an equate fault line, and say there's no earthquakes until you have an earthquake. Humans are brilliant at falling for this trick. So that external pressure is something that in Uniper has allowed us to basically corral around a single problem, which allows you to join your IT teams, your engineering teams, because they're all focused on one problem. And to be honest, the pandemic's been a great driver as well. We talked for years about using, I can't quite see it on your screen, Kevin, but I think you've got like a HoloLens and virtual kit on the shelves behind you. Now those, we played around with them for years before the pandemic. Now we use that. That is how we deliver inspections, how we do outages, how we give remote support, how we mobilize staff. We all knew it could be done before the pandemic, but under the pandemic, it is a must do. And it has now become business as normal because people realize the quality and the cost is actually better.
No, I agreed. And as you say, I've seen that with people commissioning stuff with augmented reality. Susan, you wanted to come in there with some thoughts.
Yeah, a lot of utilities are looking to leverage technology for condition-based maintenance. So there's a lot of opportunity near term to leverage technology to transition from time-based and meter-based to condition-based. So one of the things that we've worked on, and we've gotten a lot of input from utilities, are continuous online monitoring guides around different pieces of equipment, so balance of plant and some major pieces of equipment. That ties the sensors that Jack mentioned, existing sensors that are able to monitor and detect faults, known faults in pieces of equipment. So when you implement those sensors, you know specifically where to place those sensors and the type of measurement to make so that you can detect faults with some high level of assurance as to what those faults may be. When you understand what you're monitoring for in terms of faults, you can help refine those pattern recognition models, as well as make determinations of if I'm continuously monitoring certain components or aspects of an asset, I can make decisions on that time-based maintenance or inspection. And if I have some level of confidence, I can either extend those intervals or eliminate those intervals by implementing online sensors and knowing specifically what kind of data we're collecting. And we use the term intentional data, right? So we're specifically looking for some sensors with certain faults. So all of that provides a foundation to transition to condition-based maintenance and to extend those intervals and reduce cost. It then sets us up for that basis of diagnostics. So we want to move from anomaly detection that we're able to do with advanced pattern recognition to diagnostics. And so now that we have an understanding of faults, what we're detecting, what we're able to detect and what we can't, we can now introduce the machine learning on top of that, which is already being done quite successfully, I think, even neural networks and other advanced analytics. And for complex machinery, Jack also mentioned the digital twins. We can introduce those for major pieces of equipment into a diagnostic approach, all based on what data we're collecting currently and what data we understand as gaps that are tied to faults for that equipment. So it's we've kind of set up a nice, not we EPRI, but we collectively for the industry has set up a nice approach using pattern recognition and equipment reliability and all of that. So I think it's on us in the near term to take it to that next step of diagnostics. So we've kind of put that pressure on ourselves within EPRI to do that.
And if I may, Jack, you want to come in?
Yeah, just blending two of the questions that I saw come on the screen. What's different from 20 years ago if you take out all of these new solutions, and how much of this is being driven by the energy transition? A couple of changes. Number one, the emergence of in-memory processing engines that allow millions of lines of data to be processed with sub-second response and do that at a desktop level has enabled us to move from system-wide analysis down into much more granular analysis, down to individual assets in most cases. And with the energy transition, the evolution and the emergence of the electric vehicle and the projection that electrification of transport and of facilities is likely to double the electricity consumption. And if we can't manage to shift some of that to off-peak, is going to end up doubling the demand. And when you double the demand, you need to double the capacity of not just your generating sources, but your delivery network. And so if we're going to, over the next 10 years, if we're going to double the size of or capacity of our network, we're not going to do it all at once, and we're not going to do it in a peanut butter approach where it happens a little bit on each circuit. It's going to come in clusters. There are going to be some early adopters. And now we're seeing the emergence of large new databases with customer demographics and psychographics. Claritas and Nielsen and others have databases where you can actually tell a frightening amount about the occupants of a house if you put the address in. And while it may be scary to some, it's extremely valuable in predicting customer behavior and translating that into the impact that it'll have on the electricity distribution networks and gas networks as well. And so the blend of all of these is allowing companies to begin now to look at a micro level at where EVs will have this impact and where they need to be going to regulators and getting permission to double the size of networks and add new substation capacity and so on. So it's a combination of the increased capacity for processing and analysis, the emergence of new databases that are out there, and the energy transition creating new needs for that analysis.
And, Vasant, I want to come to you in a second there, but I suppose just to build on that, I've spent most of my career in the IT world, so we were always with the latest gadgets. And I suppose like some people are questioning here is that, well, what is new? And I suppose new is relative. Pete, to your point, augmented reality has been around for 15, 20 years. We've been talking about, before IoT was a thing, when I was in Intel, we used to call it the embedded business, right? So people were putting sensors, and I think, Jack, you mentioned people are now putting out obviously vibration sensors, but also sound and smell sensors, and being able to, because a lot of human capital, people will walk, I know a couple of guys and girls that will walk into a power plant and they'll go, something smells wrong, or I hear something wrong, right? Now you can put that, again, those sensors were around 20 years ago, but to your point, now you have the compute and the technology has evolved that you can actually deploy them at scale. And if I may, I just want to come to Vasant, because the other thing you mentioned, Vasant, was about the sector coupling. And I suppose my thing as well is that, yeah, the technology, the technology for technology's sake is pointless. So you have to have the business cases. Pete and Susan, everyone's called out. Vasant, you called out sector coupling. I suppose that's another angle for, here's another business case that I can use the technology, because again, I'm not doing it for technology's sake. I need to make money or save money, correct?
Yeah, sure. I thought about sector coupling because the way the energy transition is heading, that is something which, across all, I would say, regions, especially in OECD countries, policymakers are looking to, step ahead the transition by coupling different energy sectors, for example, electricity or gas. And that is because from a decarbonization perspective, there's still a long way to go in terms of emissions and so on, because over the past 10 years, renewables as part of the power generation mix has increased from 20% to 30% according to IEA, whereas conventional power has decreased from 62% to 58%. Which means that there's still, quite a way to go, and electricity only makes up 45% of global emissions. There's still transport, there's still industrial, there's still heat. So all this means that, like looking ahead, sector coupling is going to be one of the key avenues with which decarbonization is going to be accelerated. And coming back to the point on the advancements that we are seeing in terms of how operations and maintenance is being carried out, one of the key I would say pattern that we are seeing is the the ISA model, where we have 5 levels, starting from the assets to then having control, and then you are having the ERP systems at the top. We see that changing to a much more lenient tech stack, to a 3-layer model, where we have the assets, and then we have the edge computing devices or platforms. And then after that, we see something called as meta platformers. And again, we call them as GAMI, so Google, Amazon, IBM. And that is how we see things changing. And this is particularly driven by the advancements in edge computing, because that is something which can be, located close to the gateway device, the asset itself. And we have different architectures driving the change too, like the OPC, Open Process Communication, or the NAMUR architecture. And all this has actually simplified the tech stack for the customers. And I think that is one of the key things which customers also need to assist themselves when they are looking at digital transformation itself.
Alrighty. Folks, for everyone listening in, thank you for all the questions that are flying in. There's about 15 open ones right now. I've just selected a few here, and to the panelists, what I'm going to do is I'm just going to do a bit of what I call popcorn style. I'm just going to throw out a question, and anybody feel free to jump in. But there's one here around, what would you say, I suppose speaking of technology, as we've been mentioning some of it, somebody has asked, is it possible to achieve full autonomy of a power plant? Is the technology there today, Pete?
Yeah, I mean, I provoked it a bit at the start, didn't I, by saying that there isn't a big neural network that can match the human brain yet. So, okay, theoretically, on paper and design, if you built a brand new power plant, yes, you could have a fully automated plant. But there's a great breadth in what does that mean? Is it a 600 megawatt CCGT, or is it a 50 megawatt gas engine? Yeah, the smaller and the less complex the thing is, absolutely, it's more feasible. But there's still physical things that humans need to do, maintenance, etc., that maybe a robot can't do. And we're not at that point where the cost of some levels of automation is better quality and cost-wise than a human. And to just give an example of why that's the case, Susan mentioned diagnostics earlier. Now, computers are brilliant if they have thousands, tens of thousands of data sets. No human can get through that level of things, which is why computers are brilliant at image recognition, because you can feed them 10,000 images and they can recognize what the thing is. But if a computer's never seen that image before, it's got no idea what it is. My favorite is like a duck-billed platypus. Yeah, if you feed a computer a picture of a duck-billed platypus, it's got no idea what this thing is. Is it a duck, a chicken, a beaver? What is it? But a human can go, this is different. So our ability to learn from limited information is not something a computer can do yet, which is why diagnosis is the kind of next barrier we need to get over. But to reach those levels of diagnosis, you've got to have a fault database of tens of thousands, hundreds of thousands of repeat similar faults. So the machine learning and AI can recognize those things. Now in Uniper, we're quite fortunate because we've done pattern recognition for 12 years. We have over 10,000 recorded faults of all areas of plant and across all generating types, bar solar. So we can do some of that, but even that, we know that the accuracy is not high enough. So we'd have to run for another 3-4 years to get enough faults off those machine types.
Oh, okay. And I know, Jack, you mentioned earlier, you know, there's more data coming online with drones and body cameras and LiDAR and low Earth orbit satellites. We're seeing companies like Planet pulling down data. But I suppose I'll come back to, there's a couple of questions here that I'll tie in. Susan, you mentioned a lot about data as well. Pete just mentioned there that you need the data in the first place to be able to train some of the models and whatever. But somebody, there was a question in here, let me find it, from Justin Hoffman. Many of the solutions we're talking about, is this just for the big guys? And no disrespect, Pete, but like Uniper can collect that data. What about the smaller companies, smaller utilities, say in the US, munis, rural? Where do they get this data, or how can they benefit from a lot of the learnings?
Yeah, so I'll give you the EPI perspective. And Jack mentioned the quilt, right? So that is very true. And there is a space for small companies and niche solutions and folks that can maybe take things and customize it based on subject matter expertise. But how does a small utility benefit from that versus a large utility? Where does that come in? So there's a lot of challenges around that. We mentioned the limitations of the data set. So EPRI has an entire analytics platform for which we can bring in, and an AI initiative, for which we can bring in small companies and evaluate their technology. So they retain their technology, we evaluate it, and EPRI doesn't promise anything or do anything like that, we evaluate it. And so we can support them in the maturity of their technology while evaluating its applicability to, let's say, power generation assets. So there is space for them, but they have limitations of access to data, I would say is the biggest difference versus a large provider. So there's that collaboration around the maturity of analytic style technologies, data platform technologies. And so EPRI as a collaborator can bring those in and help support that. So that's the real EPRI perspective, to foster that growth. And we feel like the big players and the small players all have a role in maturing that particular area. And in terms of small utilities and big utilities, certainly the cost justification for some of that is there for the larger utilities versus the small. But we're looking at tools for the smaller utilities to where they can start with Excel and start with the free data platform, data lake processing software for them to start with their historical data. And the third point of us in terms of collaborating, not only with the spectrum of our utilities and the spectrum of the technology developers, is data, right? So these limitations of data are there. Data sharing is a big issue. And so the security of that data, how you use that data, we have all those agreements in place with our members, which we represent around the world. We work to get those data agreements in place. When we bring their data sets in, we define the use of those. Hopefully we can work on multiple projects with them. Mm-hmm. But that data set that a small utility has combined with large utilities can be very valuable, because their data sets arguably are still small data sets relative to a Google or an Apple or what's on our phones as customers. So we're trying to tackle those things, but it takes work. It doesn't happen on its own.
Okay. And before I just I'll come to Jack and Vasant in a second, but just a couple of quick ones. Yeah, the questions are flying in. We're probably not going to get to all of them in the next 15 minutes or less. But Jacob had asked there, is it necessary for utilities to effectively make a digital transformation as well to run the grid? And I suppose, Susan, to your point there is that all grid operators, they all need reliable data. They need to they're facing the exact same digital transformation requirements that whether you're a power plant or whatever, and I suppose, again, we probably won't touch on it, but somebody else mentioned here in the Q&A, we're talking about power production. What about reducing consumption? So again, the whole thing of reducing demand at the other side and demand response. But Jack, just on the topic of, from your perspective, the big guys versus the small guys, is there space for everybody?
There is, but they're going to be different solutions. The little guys are much more pragmatic and efficient. They're much more willing to compromise. I know many smaller companies that have a company picnic, and several people will go off and negotiate the union contract for the next year at the picnic. They're much more interested in low-hanging fruit. Give me the 80% solution at 5% of the cost. For them, there are a host of new solutions emerging. I did some research recently about startup companies with AI and machine learning, and found 20 of them online. All of them have very interesting products, and all of them have very low cost. So I know some of the big vendors would have you believe that their solution is ideal for your business. Caveat emptor, buyer beware. Just realize that vendors can be a very important source of information, but only one source. And other utilities are usually a much better source of information. And so collaboration, peer group sharing programs. Susan mentioned EPRI has a collaboration process that you can come in and they'll take a look at your information for you. There are a wide range of other programs out there that have similar collaborative elements to them, all of which are covered by non-disclosure agreements, confidentiality agreements, and so on. And you can really get behind the technology to get user experience. And so I strongly recommend that to everyone who's thinking about digital solutions. Alrighty.
I want to come on to the topic of people, because that's popping up in the questions, and many of you mentioned it as well. There are a couple of technology questions in there. Blockchains popped up. If anyone wants to reach out to me, I'm a big fan of blockchain technology, and there's all sorts of other stuff in there. We're not going to be able to answer everything, but folks, you'll find the connection details for all of the speakers here on the event platform, so feel free to reach out afterwards. So I'm a technology guy, gadgets and all the cool stuff, but the role of people, and Pete, you mentioned that you could do a lot of autonomous stuff, but we still need the human capability. There's a specific question that came in, caught my eye here from, whoops, where did it go? Oh, got answered. But somebody asked, do we need to retrain everybody to be digital literate? What's that doing to skills? What kind of people do we need? Because as cool as technology is, we still need jobs, right? So who wants to have a go off that one?
I'll start. All of our workers are going to become knowledge workers. They're all going to have responsibility for data initially, but ultimately they're going to be the users of data as we put mobility solutions into their hands. We can't afford to get rid of all of our people and bring in new. It's hard enough to keep our current people with the level of turnover growing in this post-COVID environment. And so, yes, we need to retrain our people, but more importantly, we need to motivate them and give them incentives and show them the value that data can provide to them in making their jobs easier.
Vasant, do you want to come in there? And I'll come to Pete and Susan.
Yeah, just quickly, Kevin, on that one, what we're also seeing is, like Jack pointed out, the value for people can also be I can say, taken up a notch by digital solutions too, where, like, for example, workforce intelligence platforms are, they are kind of increasing in adoption. And those solutions can help people in terms of gaining knowledge, and give also the operators insight on what their people are doing in terms of the operations itself, how efficient the processes are. So there's also this link that is emerging between the workforce and the operations, and that is also something that's going to be very key for digital transformation.
Alrighty. Susan, any thoughts? You mentioned in your opening statements a lot about, the data, the people, data scientists, new skills.
Yeah. So people, process, and technology. We kind of fall back on those three things. The power generation industry specifically, and the power industry has its processes. Will they be digitized over time? Fully, yes. Technology. We have parts and pieces of technology everywhere that we want to implement based on value, et cetera. The people. We have very experienced people that are going to be leaving our industry after a long time. And the percentages are high. 30 to 50%, those ranges depending on what study you look at. What we have coming in is, and so we're going to lose domain knowledge with that. What we have coming in is a young workforce that's tech savvy with no domain knowledge. So how do we leverage those digital tools in a way where these guys and gals have an expectation that it's on their phone or on their pad that they're walking around the plant? Why can I not access the drawing, the specs on this, et cetera? They're going to have that expectation, period. And we're not providing that yet. So they're going to be disenfranchised potentially, or they're going to drive us to get this in place faster.
No, it's a very valid point. And I suppose, Pete, you mentioned earlier about using augmented reality. When I was at Intel, we were off doing augmented reality pilots 10 years ago, and people say, oh, that's cool, but yeah. The pandemic, I know many companies, yourselves included, that were shipping out RealWear headsets to people to go, the best comment, one of the comments I heard last year was that the smartest person in the room is the only person in the room, because I couldn't fly in a new engineer or whatever somewhere. So the guy that was down, or the guy or the girl that was on site, I had to try and train them over the phone to how to fix something, how to commission something. So I think Susan is right. As new generation comes in, they'll expect, what do you mean I can't get all this data and things? But folks, we're coming up at 10 minutes to, we've about 5 minutes left. So what I'd like to do is, I apologize, we're not going to get to all the questions. I know Lucian and team from IIoT World will be following up with folks offline. Thank you for the great engagement, and feel free to reach out to any of the speakers on LinkedIn for specific questions. But what I want to do is kind of just go around. It's a big topic. And I suppose for folks that are listening in, what would be each one of your kind of key takeaway? If somebody's looking at digital solutions and what do I need to go do, what would be your key takeaway? So if I may, Susan, I'll start with you.
Well, first of all, thank you everybody for participating today. I thought this was a great opportunity. Excellent folks here on the panel too, and thank you. I think my point to leave everybody is, I use these two terms a lot, and they come from the government, but they're not necessarily just a government term, which is technology readiness level. So individual technologies will have a certain technology maturity, right? So we roll out at a TRL level 9 or 10, and those things are commercially available. There's also a term, and we have lots of technologies with different levels of maturity, but we're reaching that point where we have a very viable set of technologies at the higher TRL levels. What we have, or what we really don't have, is system level readiness. So that's another term. So as I put these parts and pieces together, what is my system level readiness? And I would argue that across the generation sector, our system level readiness to accept digital technologies is low. So we need to work on what that is and what that looks like. And I think we have some great people that can help with that. But that's my main point, is to think in terms of system and system level readiness. And I don't think we're there.
Okay. Instead of like the point solutions or the silos that we used to have before and stuff, right? So, okay. Jack, what would be your
my key takeaway from today for the audience is steer clear of technology for its own sake. When you're not sure, get busy looking for new options. Strengthen your worldwide listening and get better connected with your peers around the world. Knowing what they're doing and where and how they're innovating has never been more important, nor the risk of falling behind greater. As I said before, vendors can be a great source of information, but should only be one source. Make sure that you get out there actively, find channels, join groups, be part of the industry learning.
Oh, thanks, Jack. And Vasant?
Yeah, Kevin, from my perspective, I think it's important to assess digital maturity, like Susan pointed out. I think that should be the starting point for customers, and like really gauge what their needs are in terms of where they want to be and how the dynamics is in terms of where they are located, and then also look at how the industry itself is changing from a digital perspective and how that can help them. For example, we talked about autonomous power plants and how Pete pointed out about his view. And looking ahead, let's say from 5 years or 10 years down the line, how things could change. So those kind of I would say some future casting efforts will also be helpful in kind of having a present meeting their strategy in terms of be it data management or analytics, or even looking at an enterprise level view like platforms. That is also something which is really important, because with platforms you can also have an overview of different things at the same time. Like you can have an overview of the plant operations, which is both the technical side, and you can also have view of the commercial side. So that also gives a very holistic level of intelligence to customers. So from that perspective, if the problem is the business objective, again, I would like to come back to that. So digital transformation is about business objective. And based on how different or how similar business objectives are, I think that is where they need to align with a certain specific solution.
And Pete?
Yeah, so for me, the key takeaway, and those that know me quite well, will always revert back to problems or opportunities. What is the problem, opportunity that is trying to be solved? So if you can't clearly define the problem that you have with an asset, with a distribution network, with a trading situation, then you're never going to come up with a reasonable solution. So work hard on defining those problems, because when you define them well, you can bring in a group of people to solve that problem. And that's where things start to get a bit more complex. So instead of, if you've got, let's say, a maintenance problem with wind farms, and the scheduling of the maintenance, don't just bring in the maintenance teams to talk about that. Bring in your IT team, bring in your CEO, bring in a psychologist. You bring in those different viewpoints, because those people will have different solutions, different ideas to that solution. And through that discussion, in my experience, the best solutions come out. And once you've got an idea of that solution, you really need to work the solution hard, especially if that has a fairly serious digital element to it. Because one of the big problems with IT, digital things, is when they're running and they're really fast, like we are here on Teams, Zoom today, it's brilliant. But to make that solution, to get it there, takes serious amounts of time. So one thing we haven't really sped up hugely is the cycle to get to problem resolution. But once we're at the resolution, it's really fast. So don't be disheartened by the length of time it takes, and do work that solution hard to deliver the end result.
Folks that know me, I often say technology is the easy bit, and all cool and whatever, new shiny toys. But as you say, it's about, Vasant, you mentioned in terms of, look, it's the business. What are you trying to do? There's a business problem there, and how do I overcome it? How do I use that technology? And digital solutions mean many things. Susan, you mentioned the maturity model of the technology itself, and then if I may, I suppose I'd go, in different countries, in different regions, different companies are at different levels of maturity. When someone says we've implemented digitalization, it might mean something very different for one company to, you know, some guys using an iPhone, the other crowd they do have a neural network. So again, it's everybody has to understand where they fit in it. But folks, Jack, Vasant, Susan, Pete, come here, thank you so much. Again, thank you everybody for joining us. Apologies, we didn't get to all the questions. There's still about 12 or 13 open ones. Feel free to reach out to us on LinkedIn. Before we finish here, just a quick one. This is the first of, there's 5 more sessions in the Energy Day. Next up is around oil and gas. Then there's the electrification of transportation. Cybersecurity, we were talking about keeping the data safe here. We just mentioned it. There's 2 sessions later on cybersecurity and a whole one on AI for energy management, because one of the questions was that we're talking about producing energy. How do you save energy? So where's AI? So a full day ahead. I'll be listening in from over here. But again, thank you very much to the panelists. And with that, folks, have a great day. And hopefully we'll all see ourselves in the real world at some stage. But we've had 3 different continents here today. So online makes that easy. Thank you very much.